Out there, in the quiet vastness of space, where distances are measured not in miles, but in the echoes of light itself, lies a colossal mystery, the NGC 4889 galaxy. Imagine a place so immense, it dwarfs our own Milky Way, stretching across the cosmos like a titan among stars. Within its swirling arms and dark, uncharted depths, secrets lurk, objects so bizarre, so utterly unexpected, they defy everything we think we know about the universe. This isn't just another galaxy, it's a treasure chest of cosmic oddities, each one more puzzling than the last, and today we're going to uncover 30 of them. What if I told you that some of these objects glow with energies we can't explain, or drift through space in patterns that shouldn't exist? Picture structures so vast they could swallow entire solar systems without a trace, yet remain invisible to the naked eye. The NGC 4889 galaxy isn't just a collection of stars. It's a stage for phenomena that challenge the very laws of physics. Somewhere in its depths, there might even be clues to the universe's greatest mysteries: dark matter, hidden dimensions, or forces we've yet to name. The more we learn, the more we realize how little we truly understand. This journey won't be like any other. We won't just list strange objects, we'll explore the stories behind them, how they were discovered, why they baffle scientists, and what they reveal about the fabric of reality itself. From rogue black holes to unidentified radio bursts, each one holds a piece of the puzzle. And by the end, you'll see the cosmos in a way you never have before, not as a static backdrop, but as a living, evolving enigma full of questions waiting to be asked. So buckle up, we're diving into the unknown, and what we find might just change everything. At the heart of NGC 4889, lurking in the darkness like a sleeping giant, lies an unimaginable force, a supermassive black hole so enormous it makes Sagittarius A, the black hole at the center of our Milky Way, look like a mere speck. We're talking about a cosmic monster with a mass estimated at 21 billion times that of our Sun. Wrap your mind around that for a second. If you placed it in our solar system, its event horizon, the point of no return, would stretch far beyond the orbit of Pluto, engulfing planets like a shadow swallowing light. But here's the twist. This black hole isn't feasting on stars or spewing jets of radiation like the violent behemoths we often picture. Instead, it's dormant, silent, almost peaceful. That doesn't mean it's harmless, though. Its quiet state is deceptive. A black hole this size has already reshaped its entire galaxy. Billions of years ago, it likely gorged itself on gas and stars, growing to its staggering size while hurling matter across space in colossal outbursts. Now, with little left to consume in its immediate vicinity, it rests, but its gravitational grip still holds NGC 4889 in an unbreakable embrace. What makes this black hole truly fascinating is how it defies expectations. Most supermassive black holes we observe are active, powering brilliant quasars or glowing accretion disks. But this one, it's a relic of a more chaotic past, a reminder that even the most terrifying forces in the universe can go quiet. Scientists believe this dormancy offers a rare glimpse into the life cycle of these cosmic titans, what happens after they've eaten their fill and the universe around them settles into calm. And yet, calm is relative. The sheer size of this black hole means its influence never truly fades. Stars near the galactic center orbit at mind-bending speeds, whipped around by its gravity like leaves in a hurricane. If a star or gas cloud strayed too close, even now, the black hole wouldn't hesitate to awaken, proving that in the depths of space, even silence can be deadly. Stretching through the darkness around NGC 4889 like cosmic scars, ghostly ribbons of stars drift in eerie silence, the remnants of entire galaxies torn apart by unimaginable forces. These star streams, glowing faintly against the blackness, tell a story of violence on a scale we can barely comprehend. Each one is a galactic graveyard, the final traces of smaller neighbors that wandered too close to this cosmic titan and paid the ultimate price. Gravity is the sculptor here, and NGC 4889 is an artist of destruction. Over billions of years, its immense pull has stretched these victim galaxies into long, looping trails of stars, scattering them across space like crumbs from a celestial feast. Unlike the chaotic explosions we often associate with cosmic collisions, this process is slow, almost graceful, a relentless tidal force that peels stars away one by one until nothing recognizable remains. But these streams aren't just tragic relics, they're gold mines for astronomers. By studying their shapes and movements, scientists can reconstruct the galaxy's brutal history like detectives piecing together a crime scene. The way the stars are distributed reveals how fast the victim galaxies were moving when they were captured, how long ago they were devoured, and even hints about the dark matter halo surrounding NGC 4889. It's as if the streams are whispering secrets about the invisible scaffolding of the universe itself. What's truly unsettling is how common this carnage might be. Recent observations suggest dozens of these streams could be tangled around the galaxy, some so faint they're barely detectable. That means NGC 4889 didn't just consume one or two unlucky neighbors, it's likely been feasting for eons, growing fat on the stars of others. And the feast isn't over. Right now, somewhere in the darkness, another small galaxy could be spiraling toward its doom, destined to become another shimmering ribbon in this cosmic spider's web. Yet there's beauty in the destruction. These star streams, though born from violence, glow with a delicate elegance, their oldest stars often shining bluer and brighter than the galaxy's own, relics of a time before the cataclysm. They're a reminder that even in the coldest depths of space, nothing truly vanishes. It just changes form, leaving behind echoes of what once was, waiting for someone to listen. While the stars and black holes of NGC 4889 capture our attention, the real architect of this galaxy's grandeur is something we can't even see, an immense cloak of dark matter stretching far beyond its visible edges. This mysterious halo, weighing trillions of times more than our sun, is the unseen hand shaping everything within its grasp. Without it, the galaxy as we know it would fly apart, its stars scattering into the void like marbles dropped onto a tilted floor. Dark matter doesn't interact with light, making it utterly invisible to telescopes. We only know it's there because of the way its gravity tugs at the stars and gas swirling around the galaxy's outskirts. Picture a merry-go-round spinning so fast that the children clinging to it should be flung off, but instead, they hold on effortlessly, as if unseen arms are keeping them in place. That's dark matter in action, providing the extra gravity needed to keep NGC 4889 intact despite its frenetic motion. The scale of this halo is almost incomprehensible. If we could see it, it would dwarf the galaxy's luminous disk, extending up to 10 times farther into space. Within that vast volume, dark matter isn't spread evenly. It clumps and knots in ways we don't fully understand, creating invisible currents that steer the orbits of stars and even entire satellite galaxies. Some researchers think these clumps could be the seeds of future cosmic structures, or even hiding places for rogue black holes ejected during galactic collisions. What makes dark matter so maddening is how it refuses to fit neatly into our models. The way it's distributed around NGC 4889 contradicts some predictions, suggesting our theories might be missing a crucial piece. For instance, the halo appears less concentrated at the center than expected, almost as if something has been scattering it over time, like a spoon stirring honey into tea. Could this be evidence of past mergers, or does it hint at something more profound about dark matter's nature? The hunt for answers has led scientists to propose wild possibilities. Maybe dark matter isn't a single substance but multiple types, each behaving differently. or perhaps it interacts with itself through forces we've yet to discover, creating friction within the halo that reshapes its structure. Some even speculate that what we call dark matter might actually be a sign that gravity itself works differently on cosmic scales, a crack in Einstein's theory waiting to be explored. Every observation of NGC 4889's dark matter halo deepens the mystery, as we map its subtle influence on starlight bending around the galaxy, a phenomenon called gravitational lensing. The data reveals gaps and inconsistencies that keep astronomers awake at night. This invisible giant isn't just holding the galaxy together, it's holding up a mirror to the limits of our understanding, daring us to look deeper. And somewhere in that darkness, the next revolution in physics might be waiting. Flowing like a wisp of smoke against the colossal backdrop of NGC 4889, one of its most enigmatic companions defies everything we expect from a galaxy. This ghostly structure, known as an ultra-diffuse galaxy, stretches across tens of thousands of light years, yet contains so few stars it's nearly transparent. If you could hold it in your hand, it would feel like clutching a handful of fog. Its sparse stars scattered so thinly that entire regions could fit our Milky Way without a single stellar encounter. What makes this galaxy extraordinary isn't just its faintness, but its survival. Nestled in the gravitational grip of a titan like NGC 4889, most fragile structures would be shredded into star streams, yet this wisp persists. Astronomers compare it to a feather floating unscathed through a hurricane. Its stars drift so far apart that collisions are virtually impossible, and its delicate balance hints at an unexpected resilience. Some suggest it's wrapped in an unusually thick cocoon of dark matter, acting as an invisible shield against disruption. Others propose it's a failed galaxy, one that never gathered enough gas to ignite prolific star formation, leaving it frozen in a state of cosmic adolescence. The real puzzle lies in how such a fragile object ended up here at all. Ultra-diffuse galaxies are typically found in quieter cosmic neighborhoods, not anchored to monsters like NGC 4889. Its presence challenges assumptions about how galaxies form in dense, violent environments. Was it born this way, or did its stars get stripped away over time? Observations reveal another oddity. Its remaining stars are ancient, some nearly as old as the universe itself, with almost none of the younger, bluer stars seen in more active galaxies. This suggests it's been dormant for billions of years, a relic from the early cosmos somehow preserved in this unlikely place. Studying this faint companion is like reading a missing page from galactic history. Its survival hints at hidden forces at work, while its star-poor expanse offers clues about how extreme environments shape cosmic evolution. If galaxies were songs, this one would be a whisper, one that just might change how we hear the symphony of the universe. Spanning millions of light years like invisible echoes of ancient violence, the colossal radio lobes of NGC 4889 stretch far beyond the galaxy's visible edges, ghostly remnants of a time when its central black hole ruled as an active galactic nucleus. These enormous bubbles, detectable only through radio telescopes, are the aftermath of a celestial tantrum, where unimaginable energies once blasted outward at nearly the speed of light. Today, they linger as fading signatures, offering astronomers a rare window into the galaxy's explosive past. The lobes formed when the supermassive black hole was in its active phase, gorging on surrounding matter and converting it into immense jets of plasma. Picture a cosmic fire hose, shooting twin beams of charged particles so powerful they punch through intergalactic space, inflating these gargantuan structures over hundreds of millions of years. At their peak, these jets would have outshone the entire galaxy in radio waves, lighting up the universe like a beacon. But now, with the black hole dormant, the lobes are cooling and dispersing, their energy slowly dissipating into the void like steam from a forgotten cup of tea. What makes these structures so puzzling is their sheer persistence. Even after the black hole's jets shut off, the lobes haven't collapsed. They're being held up by magnetic fields woven into their fabric, like delicate balloons reinforced with invisible threads. As these fields weaken, the lobes are beginning to ripple and fragment, creating intricate substructures that resemble the frayed edges of a torn cloth. Some regions glow brighter in radio waves, hinting at shock waves where collapsing material reignites briefly, like embers flaring in a dying fire, but the story doesn't end there. These fading giants are now interacting with the surrounding intergalactic medium, creating pressure waves that ripple through the cosmos. In some areas, the lobe's outer shells are being compressed by the tenuous gas between galaxies, triggering sporadic bursts of particle acceleration. It's as if the lobes are whispering their final secrets to the universe, imprinting their history onto the fabric of space itself before they vanish entirely. For scientists, these decaying structures are cosmic archaeology. By mapping their faint emissions, they can reconstruct the black hole's feeding frenzies from eons ago, how much it consumed, how violently it expelled material, even how its outbursts might have influenced nearby galaxies. The lobes also challenge our understanding of how such energetic events evolve over time. Why do some fade smoothly while others flicker unpredictably? Could there still be weak, intermittent activity deep within the galaxy's core, like a sleeping beast occasionally stirring? One theory suggests these lobes might seed future phenomena, their dispersing particles enriching the intergalactic medium with heavy elements that could one day form new stars or even planets. Another proposes that their slow death throes could be masking subtle signs of renewed activity, hinting that the black hole's slumber might not be as peaceful as it seems. Whatever the truth, these fading radio ghosts remind us that even the mightiest cosmic structures are temporary, their legacies written in wavelengths only the most patient observers can read. Scattered like cosmic fireflies around NGC 4889, dozens of globular clusters orbit in silent grandeur, each one a dense, glittering island of stars older than the galaxy itself. These ancient spheres, packed with hundreds of thousands of stellar inhabitants, are among the oldest structures in the universe, time capsules preserving the conditions of the cosmos just after the Big Bang. Unlike the galaxy's younger, metal-rich stars, these clusters glow with the golden light of primordial suns, their chemistry untouched by generations of stellar recycling. The sheer number of globular clusters around NGC 4889 is staggering. While our Milky Way hosts about 150 of them, this giant galaxy could have thousands, each orbiting like a loyal sentinel. Their distribution reveals a hidden history. Many didn't form here originally but were stolen during galactic collisions, ripped from smaller galaxies that fell victim to NGC 4889's gravitational pull. This cosmic plunder left behind a halo of clusters with wildly different orbits, some looping close to the galaxy's core while others drift in far-flung, eccentric paths. What's inside these clusters defies expectation. Their stars are so densely packed that if you stood on a planet in one, the night sky would blaze with thousands of stars visible to the naked eye, some so bright they'd cast shadows. Despite this proximity, stellar collisions are rare. The clusters have had billions of years to settle into stable, albeit crowded, equilibriums. Many host bizarre stellar relics, like blue straggler stars that somehow appear younger than their surroundings, possibly rejuvenated by stealing material from neighbors. Others contain pulsars spinning silently in the darkness, their precise flashes acting as cosmic clocks. The true value of these clusters lies in what they tell us about the early universe. Their stars contain almost none of the heavy elements forged in supernova, marking them as products of a time before the cosmos was enriched with metals. Studying their light is like reading a recipe from the universe's first kitchen, one where ingredients were simpler, purer. This lack of metals also suggests they formed in an era before rampant star death had seeded space with heavier atoms, making them perfect benchmarks for testing theories about cosmic evolution. Yet mysteries linger. Some clusters orbit in unexpected directions, moving backward relative to the galaxy's rotation, a sign they were captured during violent mergers. Others show subtle chemical variations, hinting that they might be the cause of devoured dwarf galaxies, stripped of their outer stars until only their brightest hearts remained. Then there are the dark globular clusters, which emit far less light than their star counts suggest, possibly due to lurking black holes or excess dark matter tugging at their interiors. For astronomers, these clusters are more than celestial curiosities. Their ages act as cosmic yardsticks, helping measure the universe's expansion rate. Their motions trace the invisible tendrils of NGC 4889's dark matter halo, and their survival against all odds through collisions, tidal forces, and the galaxy's immense gravity makes them resilient witnesses to eons of cosmic history. They remind us that even in a universe of chaos, some things endure, carrying stories written in starlight across nearly 14 billion years. Hanging like a torn rag in the cosmic winds, a dwarf galaxy teeters on the edge of oblivion, its stars being methodically peeled away by NGC 4889's relentless gravity. This isn't a quick demise, it's a slow, almost poetic unraveling, a dance of destruction spanning hundreds of millions of years. The victim's core still clings together, a faint smudge of light against the larger galaxy's glow, but its outer regions have already been stretched into shimmering tendrils, each one a highway of stolen stars streaming toward their new home. The process is mesmerizing in its violence. As the dwarf galaxy spirals closer, tidal forces, the difference in gravity between its near and far sides act like invisible hands tearing it apart. Stars aren't ripped away all at once, they're gently tugged loose one by one like petals plucked from a flower. These orphaned stars now form delicate, looping arcs around NGC 4889, their paths tracing the ghostly outline of the dwarf's original orbit. Some are flung ahead like cosmic debris, while others lag behind, creating a smear of light that astronomers call tidal tails, celestial breadcrumbs marking the galaxy's demise. What's truly astonishing is how much we can learn from this destruction. The dwarf's remaining core glows with a distinct hue, its stars richer in heavy elements than NGC 4889's outermost halo. This chemical fingerprint reveals it wasn't just passing by. It was a thriving mini-galaxy with its own history of star formation before it wandered too close. Now, as its gas is stripped away, any newborn stars within it are abruptly cut off from their fuel supply, leaving behind a population of aging suns destined to fade into the larger galaxy's backdrop. The real spectacle lies in the details. High-resolution images show the dwarf's disk warping dramatically, its shape distorted like a vinyl record left in the sun. Some of its globular clusters, once neatly orbiting its center, now drift freely, tossed into chaotic paths by the encounter. A few might even survive as independent clusters long after their parent galaxy is gone, like children orphaned in a storm. Meanwhile, the influx of fresh stars is subtly altering NGC 4889's outer halo, enriching it with metals and adding to the tapestry of its growth. This carnage isn't unique, but its visibility is rare. Most mergers happen too far away or too dimly for us to witness in such detail. Here, we're catching the act mid-performance, a front-row seat to the universe's relentless cycle of creation and destruction. And somewhere in that fading glow, there's a lesson about our own Milky Way's fate, a reminder that even galaxies are temporary, their stories written in the stars they steal and the trails they leave behind. Hidden in the glow of NGC 4889's core, a flickering X-ray source pulses with no visible counterpart, a cosmic phantom radiating energy with no obvious origin. This mysterious emitter, detected by space telescopes but invisible to optical instruments, defies easy explanation. It's not the galaxy's central black hole which lies dormant, nor is it part of any known star or nebula. Instead, it flickers unpredictably, sometimes flaring brightly before vanishing for months, as if playing a game of celestial hide and seek. Theories about its identity range from the exotic to the unprecedented. One leading idea suggests an intermediate mass black hole, smaller than the galaxy's supermassive monster but still thousands of times heavier than our Sun, could be lurking here. Such objects are notoriously hard to find, but their gravitational pull would explain the intense X-rays as they siphon gas from unseen surroundings. Alternatively, it might be a hyperactive neutron star, a city-sized remnant of a supernova, spinning rapidly and hurling beams of radiation like a lighthouse in the dark. But there's a twist. The emission patterns don't quite match known black hole or neutron star behavior. The flares arrive irregularly with no clear periodicity, and their energy spectra contain anomalies that leave astronomers scratching their heads. Some speculate this could be something even rarer, a quasar remnant, the dying embers of a once bright active nucleus, or perhaps a dense cluster of white dwarfs colliding in slow motion, their violent interactions producing bursts of high-energy light. The phantom's location deepens the puzzle. Nestled close to the galaxy's core but offset just enough to avoid being swallowed by the central black hole, it occupies a gravitational sweet spot, a place where matter could accumulate without being immediately consumed. If it is a black hole, its survival there suggests a delicate balancing act, like a moth circling a flame without getting burned. Observations hint at a faint disk of material swirling around it, but the disk's composition remains unclear. Is it gas, shredded stars, or something more unusual? Every flicker from this source carries clues. During its brightest flares, analysis reveals traces of iron and other heavy elements in the X-ray spectrum, implying it's feeding on something metal-rich, perhaps the remnants of a torn-apart star or a long-vanished stellar nursery. Yet when it goes quiet, even the most sensitive instruments struggle to detect anything at all, as if it's slipping into another dimension. This behavior has led some researchers to propose radical alternatives, like a primordial black hole from the early universe or an exotic object predicted by string theory. For now, the phantom remains an enigma, its true nature locked in the data. But each new observation brings us closer to an answer, and perhaps to rewriting the rules of what we thought possible in the depths of space. Streaking through the outskirts of NGC 4889 like a shrapnel fragment from an ancient explosion, a lone supernova remnant races away at a staggering 6 million miles per hour, fast enough to cross the distance from Earth to the Moon in under 4 minutes. This cosmic runaway, a twisted knot of gas and dust glowing faintly in X-rays and radio waves, shouldn't be here. Supernova remnants typically linger near their birthplaces, expanding slowly into the surrounding space. But this one, it's fleeing the galaxy as if propelled by some unseen force, leaving a glowing trail of ionized gas in its wake. The violence that launched it must have been unimaginable. Most supernova explode symmetrically, their remnants expanding outward in a roughly spherical shell. But this object's skewed shape and blistering speed suggest it was catapulted during an asymmetric detonation, a stellar explosion so lopsided, the recoil sent the remnant careening like a cannonball. One leading theory points to a binary star system where one star went supernova. Its sudden mass lost violently ejecting its companion along with the debris. Another possibility involves a hypervelocity neutron star, born in the blast, now rocketing away unseen while its remnant follows like cosmic exhaust. Clues hide in the remnant's chemistry. Spectroscopic analysis reveals heavy elements like oxygen, neon, and silicon forged in the supernova's heart, but their distribution is patchy, as if the explosion scrambled them unevenly. The gas is also unusually hot, suggesting recent shock waves from collisions with interstellar material. Yet the true smoking gun lies in its trajectory. By tracing its path backward, astronomers found it lines up perfectly with a dense star cluster near the galaxy's core. That cluster, packed with short-lived massive stars, is a likely birthplace for the doomed progenitor. What's astonishing is how long this remnant has survived its journey. Supernova remnants usually fade within 100,000 years as they mix with interstellar gas. But this one, despite traveling for perhaps millions of years, remains intact, its structure preserved by the low-density environment of the galactic halo. It's like a bullet fired through fog, leaving a clean tunnel in its wake. The surrounding gas, too thin to slow it down significantly, allows the remnant to maintain its frenetic pace. This runaway raises profound questions about the extremes of stellar death. Was its progenitor a rare supermassive star that collapsed directly into a black hole, releasing a directed energy jet that kicked the remnant outward? Or could it have been hurled away by a close encounter with the galaxy's central black hole long before exploding? The answers might rewrite our understanding of how galaxies redistribute matter and how the echoes of cataclysms can linger, visible long after their creators have vanished. Stretching across the cosmic void like an invisible umbilical cord, a faint but immense bridge of superheated gas silently links NGC 4889 to one of its neighboring galaxies, a filament so vast it could span the Milky Way 10 times over. This intergalactic tether, glowing faintly in X-ray wavelengths, is no static structure. It's a dynamic highway of matter, ferrying gas between galaxies at temperatures reaching millions of degrees. Astronomers call it a ram pressure stripping tail, but its true significance lies in the story it tells about how galaxies feed, grow, and interact over billions of years. The bridge's origins trace back to a gravitational tug-of-war. As NGC 4889 and its neighbor drifted closer together, their mutual pull began to distort the tenuous gas halos surrounding each galaxy. But the real sculptor here isn't just gravity, it's motion. The galaxies are moving through a denser region of their cluster, where intergalactic gas acts like a relentless headwind. Picture two boats sailing side by side through thick fog, their wakes blending into a single trailing plume. That's what's happening here. The gas from both galaxies is being swept backward by this cosmic breeze, leaving behind a glowing trail that marks their passage through space. What makes this bridge extraordinary is its longevity. Unlike tidal tails formed during brief galactic collisions, this structure has persisted for hundreds of millions of years, continuously replenished by fresh gas stripped from both galaxies. Spectroscopy reveals a rich mix of elements, hydrogen, helium, and traces of heavier metals, proof that it's carrying away material that could have formed new stars. Somewhere along this filament, pockets of gas are collapsing under their own gravity, forming embryonic star clusters that glow like fireflies along a dark river. For astronomers, such bridges are more than curiosities, they're lifelines. Galaxies in dense clusters often starve as their gas reserves are stripped away, quenching star formation. But this structure shows how gas can sometimes flow between galaxies, offering a temporary reprieve. NGC 4889 might be siphoning fuel from its neighbor, extending its own era of stellar birth even as it contributes to the other galaxy's slow decline. It's a cosmic balancing act where the very process that drains one galaxy nourishes another. The bridge also hints at a hidden architecture. Its twists and kinks suggest the influence of dark matter, whose gravity weaves invisible pathways along which the gas flows. Some sections appear brighter, marking regions where turbulence or magnetic fields are concentrating the material like knots in a rope. And at its faintest edges, the gas disperses into the cluster's vast reservoir, a reminder that even the grandest structures are fleeting on cosmic timescales. Yet the most tantalizing possibility lies in what this bridge leaves behind. Over billions of years, as the galaxies drift apart, the filament will fade, but the gas it deposited might spark new generations of stars or even seed future galactic mergers. It's a slow-motion exchange, one that transforms both galaxies in ways we're only beginning to understand. And somewhere in that glowing river of gas, there might be answers to one of astronomy's biggest questions: how the universe's largest structures share the very stuff of creation. Among the glittering sea of stars and gas in NGC 4889, one object shines with the brilliance of a quasar, but something about it isn't right. This dazzling source of light, blazing across billions of light years, carries all the hallmarks of a classic active galactic nucleus: intense radiation, a luminous core, and jets of material spewing outward. Yet when astronomers train their spectrographs on it, the data tells a stranger story. Its spectral lines, the chemical fingerprints embedded in its light, don't match any known quasar. Instead, they ripple with anomalies, as if the universe is playing a cosmic prank. The possibilities are as intriguing as they are conflicting. One camp argues this could be a rare type of active galaxy we've simply never seen before, one where the supermassive black hole is feeding on a highly unusual diet. Normally, quasars show strong emission lines from elements like hydrogen, helium, and carbon. But this object's spectra reveal unexpected spikes of neon and magnesium, along with bizarrely broad absorption lines that suggest gas is racing away from the core at unprecedented speeds. Some theorize the black hole might be devouring a star rich in these elements, or perhaps it's surrounded by a dense, metal-enriched cloud unlike anything in typical AGNs. But there's a catch. Another faction points out this could be a case of cosmic illusion, a foreground object like a distant quasar or even a lone neutron star, perfectly aligned between us and NGC 4889. The galaxy's immense size makes such coincidences more likely, like holding a flashlight behind a frosted window and mistaking its glow for something inside. If true, the spectral oddities might stem from material in the imposter's immediate surroundings, not the galaxy itself. Supporting this, the object's position is slightly offset from NGC 4889's core, and its redshift, a measure of its distance, shows subtle inconsistencies with the galaxy's well-documented motion. The debate hinges on a deeper mystery. How often do we misread the cosmos? Active galaxies come in staggering varieties, and astronomers are still compiling an atlas of their behaviors. This could be a missing page in that catalog, a black hole operating under extreme conditions, perhaps in a late-stage merger where its accretion disk is laced with debris from a cannibalized companion. Or it might be a reminder that the universe loves to hide its truths in plain sight, letting overlapping objects masquerade as something they're not. For now, the imposter keeps its secrets. Further observations are peeling back the layers, searching for telltale signs like variability in its brightness or polarization in its light that could reveal its true nature. Whatever the answer, it challenges our certainty about what lurks in the hearts of galaxies, and how easily even the brightest lights can deceive us. Nestled among the glittering star clusters of NGC 4889, one particular grouping stands out for all the wrong reasons. It barely glows at all. This enigmatic assembly, catalogued as a globular cluster, weighs as much as a small galaxy yet emits only a fraction of the light it should. The numbers defy logic. Measurements suggest its mass could be millions of times that of our Sun, but its visible starlight amounts to little more than a faint smudge against the cosmic backdrop. Astronomers call this a dark star cluster, and its existence throws a wrench into everything we thought we knew about how these ancient structures form. What's stealing its light? The leading theory points to dark matter, an invisible substance that outweighs normal matter 5 to 1 in the universe. Typical globular clusters contain almost none of it, making this one a glaring exception. If dark matter does lurk here, it could mean the cluster isn't a true globular at all, but the stripped-down core of a dwarf galaxy, its outer stars ripped away long ago by tidal forces, leaving behind a dense knot of dark matter and surviving stars. Supporting this idea, the cluster's stars move faster than gravity from visible matter alone can explain, as if tethered by unseen anchors, but alternative explanations are just as compelling. The cluster might be packed with failed stars, brown dwarfs too small to ignite nuclear fusion, or cold, dead stellar remnants like white dwarfs and neutron stars. These objects would contribute mass without much light, like invisible logs on a weighing scale. Some astronomers even speculate about rogue planets ejected from their systems and now drifting freely in the cluster's grip, adding bulk without a flicker of illumination. The darkest possibility, primordial black holes, ancient relics from the Big Bang. These hypothetical objects could be peppered throughout the cluster, their collective gravity binding it together. If they exist, they'd be nearly impossible to spot directly, leaving only their gravitational signature as evidence. What makes this cluster so valuable is its rarity. Of the thousands known in the universe, only a handful exhibit this extreme mismatch between mass and light. Studying it could reveal whether dark matter can clump on small scales, a test for theories about how the universe structures itself. Or it might expose gaps in our understanding of stellar evolution, showing how environments like this can produce an overabundance of dark, failed stars. Every observation deepens the puzzle. Recent infrared surveys hint at a faint, uniform glow between the cluster's visible stars, perhaps the combined light of countless dim objects, or even the thermal whisper of warm dark matter. Meanwhile, its outer stars orbit in unexpected patterns, some moving nearly perpendicular to the cluster's rotation, as if pushed by unseen hands. This shadowy gathering forces us to reconsider what a star cluster can be. Is it a cosmic accident, a relic of violence, or a signpost to physics we've yet to uncover? One thing's certain, in the black heart of this cluster, the universe is hiding something extraordinary. Bending the very fabric of space around it, NGC 4889 acts as a colossal cosmic magnifying glass, its immense gravity warping the light from distant galaxies behind it into eerie, stretched arcs. This phenomenon, called gravitational lensing, typically follows predictable patterns. The more massive the foreground galaxy, the more extreme the distortion. But one particular background galaxy, twisted into a smeared halo of light, refuses to play by the rules. The way its image bends suggests there's far more mass warping space near NGC 4889 than we can account for, as if an invisible giant lurks just beyond our sight. The anomaly becomes clear when astronomers map the lensing effect against the galaxy's visible matter. Based on the positions and brightness of NGC 4889 stars and gas, computer models predict how the background galaxy should appear, yet the real image is skewed in ways these calculations can't explain. Some arcs split into multiple copies, like reflections in a funhouse mirror, while others stretch thinner than expected, hinting at pockets of concentrated gravity where no stars or gas clouds are visible. It's as if the galaxy is surrounded by phantom masses, tugging at light beams like unseen hands. One leading explanation points to rogue dark matter clumps, invisible subhalos drifting through NGC 4889's outskirts like cosmic ghosts. These structures, predicted by theories but notoriously hard to detect, could be the missing pieces distorting the lens. Alternatively, there might be entire dwarf galaxies hidden in the darkness, their stars too faint to spot but their collective gravity enough to alter the lensing pattern. The most tantalizing possibility, a population of ancient black holes ejected during the galaxy's chaotic past and now floating freely, their presence betrayed only by how they warp the light passing near them. Zooming in on the distorted arcs reveals another clue: tiny, flickering brightness variations. These could be microlensing events, brief flashes caused by compact objects within NGC 4889, passing in front of individual stars in the background galaxy. If confirmed, these flickers would act as breadcrumbs, marking the locations of otherwise invisible masses. Some flickers last days, suggesting planet-sized objects. Others persist for weeks, hinting at stellar mass black holes or neutron stars. Together, they paint a picture of a galaxy teeming with unseen structures, a hidden architecture woven into its gravitational field. What makes this anomaly so valuable is its potential to unravel two mysteries at once. By studying how the lensing defies expectations, astronomers can probe the distribution of dark matter on scales too small for traditional detection methods. Simultaneously, the distortions serve as a stress test for Einstein's theory of general relativity. If the warping can't be explained by known physics, it might hint at new gravitational phenomena. Every unexplained kink in those luminous arcs is a question waiting to be answered, a whisper from the universe's hidden layers, and somewhere in those bent beams of light, we might just find the keys to understanding what NGC 4889 and the cosmos itself is truly made of. Streaking through the void like a cosmic bullet, a lone star races away from NGC 4889 at over 2 million miles per hour, fast enough to cross the distance from New York to Los Angeles in under 2 seconds. This hypervelocity star, a rogue fugitive from its home galaxy, shouldn't exist under normal circumstances. Stars are bound tightly to their galaxies by gravity, yet this one has broken free with enough energy to escape entirely, destined to drift forever in intergalactic space. Its trajectory tells a violent story, a gravitational slingshot so extreme it defies belief. Tracing its path backward leads directly to the galaxy's core and to the supermassive black hole lurking there. The math is undeniable. For a star to reach such speeds, it must have been part of a binary system that wandered too close to the black hole's event horizon. As one star was captured and shredded by tidal forces, the other was flung outward like a stone from a sling, accelerated to velocities that left gravity in the dust. Simulations show the exact moment of ejection, a precise dance where the black hole's spin and the star's orbit aligned perfectly, converting orbital energy into raw speed. The result was a celestial cannon shot propelling this star across the galaxy and beyond. What's astonishing is how long it survived the journey. Hypervelocity stars are rare, only a handful have been spotted in our own Milky Way, but this one stands out for its endurance. Most are hot, young blue stars with short lifespans, burning out long before they escape their galaxies. Yet this traveler is older, cooler, and yellower, suggesting it's been racing through space for hundreds of millions of years. Somehow, it avoided collisions, avoided stripping away its outer layers, even avoided the gravitational traps of other massive objects along its path. Spectroscopy reveals another clue. Its composition is oddly metal-rich, laden with elements like iron and silicon that typically form near galactic centers. This fingerprint confirms its birthplace in NGC 4889's crowded core, where generations of supernova enriched the environment with heavy elements. But there's a twist. Its atmosphere also contains traces of lithium, an element usually destroyed early in a star's life. This suggests it might have ingested material from a companion star before its violent ejection, carrying a chemical time capsule from its past. Now, as it crosses the gulf between galaxies, this star carries more than just its own story. Its speed offers a rare chance to measure the gravitational potential of NGC 4889's dark matter halo, how much invisible mass had to tug on it to slow its escape even slightly. Its trajectory acts as a probe, mapping the distribution of matter in intergalactic space as subtle deflections alter its course. And its isolation makes it a pristine laboratory for studying stellar evolution outside the turbulent environment of a galaxy. But the greatest mystery remains. Where is it headed? Current projections place it on a course toward the vast emptiness between galaxy clusters, where it will drift alone for billions of years. Long after NGC 4889 has merged with neighboring galaxies, long after its central black hole has awakened again, this star will still be traveling, a silent witness to the moment gravity hurled it into the unknown. Whirling around NGC 4889 like a tilted crown, a bizarre ring of stars and gas orbits at a near perpendicular angle to the galaxy's main disk. a structure so unusual it defies the orderly rotations we expect from spiral galaxies. This polar ring, as astronomers call it, isn't just a cosmic oddity. It's a fossilized record of violence, a remnant from a time when another galaxy strayed too close and was torn apart by gravitational forces. The ring stars move in a nearly vertical path compared to the galaxy's flat plane, tracing a luminous circle that loops over the poles like a celestial hula hoop. Theories about its origins point to a cataclysmic collision billions of years ago. When two galaxies merge, their interactions can fling stars and gas into chaotic orbits, but for material to settle into such a precise perpendicular ring requires a very specific dance. One scenario suggests a smaller galaxy, rich in gas, once skirted NGC 4889's edge at just the right angle. As it was shredded by tidal forces, its debris spread into a rotating disk aligned with the larger galaxy's poles, held in place by the delicate balance of gravity and momentum. Another possibility involves a near head-on collision, where the victim galaxy's orbit was so steeply inclined that its remains swirled into this upright configuration. Clues lie in the ring's composition. Unlike the galaxy's main disk where stars are older and metal-rich from generations of supernova, the polar ring hosts younger, bluer stars and pockets of ionized gas. This suggests it formed from fresh material, likely the gas reserves of the devoured galaxy, which later collapsed to birth new stars. Spectroscopy reveals another twist. Some regions of the ring rotate backward relative to the galaxy's spin, like a wheel turning the wrong way. This counter-rotation hints at multiple merger events where conflicting gravitational kicks left parts of the ring moving in opposition. The ring isn't static, it's a dynamic structure slowly eroding. Gravitational perturbations from NGC 4889's central bulge and dark matter halo are gradually warping its shape, causing some stars to drift inward while others spiral away. In a few 100 million years, this celestial crown may dissolve entirely, its stars assimilated into the galaxy's halo. Yet for now, it stands as a striking testament to the chaos of galactic evolution, a reminder that even the most majestic structures in the universe are born from violence. What makes this polar ring especially valuable is its rarity. Fewer than 1 in 10,000 galaxies host such well-defined perpendicular structures, making each one a laboratory for testing theories about galactic interactions. By studying how its stars move, astronomers can map the galaxy's gravitational field in 3 dimensions, revealing hidden asymmetries in its dark matter distribution. The ring also offers a glimpse into how galaxies recycle material, showing how stolen gas can ignite new stellar generations far from where they were born. Perhaps most intriguing is the lingering mystery of its stability. Simulations struggle to replicate how such a ring could persist for billions of years without dispersing. Some hidden mechanism may be subtle magnetic fields or the gravitational influence of an unseen dwarf galaxy must be acting as cosmic glue, holding this fragile structure together against all odds. Until we solve that puzzle, the polar ring remains both a masterpiece of celestial mechanics and a challenge to everything we think we know about how galaxies grow. Glowing like an ember in the cosmic dark, a peculiar blob of infrared light clings stubbornly to the outskirts of NGC 4889, a patch of space that shouldn't be this bright. Unlike the rest of the galaxy's cool, scattered dust, this region blazes with thermal energy, emitting wavelengths that hint at temperatures far too high for ordinary interstellar material. Something is heating it up. The question is, what? One possibility is a hidden starburst, a frenzied nursery where stars are being born at a rate hundreds of times faster than in our entire Milky Way. Buried deep within the dusty cloud, countless young stars could be igniting simultaneously, their fierce ultraviolet radiation absorbed by surrounding dust and re-emitted as infrared glow. If true, this blob would be a cosmic pressure cooker where gravity has compressed gas to the breaking point, triggering a chain reaction of stellar births. Supporting this idea, radio telescopes have detected faint whispers of methanol and water vapor, molecules often found in dense stellar nurseries, but there's a rival explanation that's even more exotic. The blob's energy output doesn't quite match typical starburst patterns. Instead, its spectrum bears the hallmarks of an active galactic nucleus, a supermassive black hole shrouded in so much dust, even X-rays struggle to escape. Only the faintest hints of high-energy radiation leak through, like flashlight beams dimmed by thick fog. If a black hole lurks here, it's dining in secret. It's a crescent disk hidden behind walls of debris torn from disrupted stars or a cannibalized dwarf galaxy. The debate hinges on subtle clues. The blob's infrared signature shows unusual spikes at specific wavelengths, suggesting the presence of rare dust grains crystallized by intense heat, exactly what you'd expect near a black hole's energetic outflow. Yet other features resemble shock waves from supernova explosions, which would point to a starburst. The truth might lie in the middle. Perhaps both phenomena coexist, with the black hole's activity fueling star formation by compressing nearby gas, or vice versa, new stars funneling material toward the hidden monster. What makes this blob so fascinating is its isolation. Most infrared bright regions sit near galactic cores, not adrift in the halo. If it's a starburst, how did enough gas accumulate here, far from the denser inner disk? If it's a black hole, how did it get kicked out from the center? One tantalizing theory suggests the blob might be the mangled remains of a recently devoured dwarf galaxy, its gas compressed and heated during the collision. As telescopes gather more data, the mystery deepens. Recent observations reveal the blob is drifting slightly, its motion mismatched with the galaxy's rotation, as if it's still settling from some ancient upheaval. Whether it's a hidden inferno of newborn stars or a cloaked cosmic predator, one thing's certain: in the shadows of NGC 4889, even the faintest glow can rewrite the rules. Deep within the swirling heart of NGC 4889, some astronomers report glimpsing something impossible, a second nucleus glowing beside the galaxy's supermassive black hole. This apparent twin core, visible in certain telescope exposures, would rewrite our understanding of galactic anatomy if real. But the universe loves a good illusion, and this one dances on the edge between discovery and deception. The first clue that something's amiss comes from the second nucleus itself. Unlike the galaxy's true core, a defined, compact region powered by the black hole's gravity, this phantom appears fuzzier, its light unevenly distributed. Advanced imaging reveals it lacks the telltale radiation signatures of an active nucleus, like the high-energy X-rays or polarized light emitted by swirling accretion disks. Instead, its spectrum matches the blended glow of countless older stars, packed unusually tight. So what's creating this cosmic doppelganger? One compelling answer lies in the dynamics of starlight. NGC 4889's core is so densely packed that stars orbit at breathtaking speeds, some whipping around the black hole at thousands of miles per second. When telescopes capture this region, the sheer concentration of stars combined with their frenetic motion can create artifacts. Imagine photographing a spinning firework. The streaks of light might merge into a bright smudge that resembles a separate object. Similarly, stars on elongated orbits may appear to cluster at certain points, tricking our instruments into seeing a phantom nucleus. Yet there's another, even stranger possibility. If a massive star cluster or a smaller black hole happen to drift into alignment with the true core along our line of sight, their combined gravity could lens background starlight, amplifying and distorting it into a secondary bright spot. Simulations show such alignments are rare but plausible in galaxies this size, where millions of objects jostle for position. Supporting this, the second nucleus sometimes shifts slightly between observations, a flicker that matches the expected motion of an intervening object. The most tantalizing theory involves a cosmic near-miss. Billions of years ago, another galaxy might have grazed NGC 4889, depositing a dense knot of stars near its center. As this cluster orbits, it could periodically swing close enough to the black hole to appear nucleus-like before retreating into the stellar sea. Infrared observations hint at a faint trail of stars leading away from the phantom, like breadcrumbs marking its path, evidence that might support this galactic theft scenario. Whatever the truth, the illusion teaches us a valuable lesson. Even in an age of advanced telescopes, the universe still finds ways to make us question what we see. Every unexplained glow, every flicker of light forces us to sharpen our tools and our thinking, to distinguish cosmic reality from the shadows it casts. And sometimes the most fascinating discoveries aren't the objects themselves, but the puzzles they leave behind. Amid the swirling stars and glowing gas of NGC 4889, there exists a pocket of near-nothingness, a void where the usual cosmic clutter thins to almost nothing. Yet this emptiness hums with an invisible power, magnetic fields strong enough to twist the paths of charged particles, weaving patterns through space where almost no matter exists to carry them. It's as if the galaxy has etched an invisible fingerprint onto the void, a force lingering long after the substance that created it has faded away. How can magnetism survive in such isolation? Normally, magnetic fields need electric currents moving charges. To sustain them, strip away the matter, and the field should dissipate like smoke in the wind. Yet here they endure, curling through space with no obvious source. One theory points to the ghosts of dead stars. When massive stars collapse into neutron stars or black holes, their final moments can unleash magnetic shocks so powerful they imprint onto the surrounding space like a cosmic branding iron. Even after the star's matter is gone, the magnetic echo lingers, a relic of its violent death. Another possibility is even stranger. Quantum physics suggests that the vacuum of space isn't truly empty. It seethes with virtual particles flickering in and out of existence. Under extreme conditions, like those near a supermassive black hole, these fleeting particles could briefly align, creating microscopic currents that sustain magnetic fields on vast scales. It's like a hall of mirrors where infinitesimal effects amplify into something colossal. The void's magnetism isn't just a curiosity, it's a cosmic tool. Charged particles caught in these fields spiral along their lines, emitting faint radio waves that astronomers can detect. By mapping those signals, scientists have traced the field's structure, great arcs and loops stretching across hundreds of light years, some twisted like braided rope. These shapes hint at ancient turbulence, perhaps from jets ejected by the galaxy's central black hole billions of years ago. The fields act as fossilized records, preserving the imprint of forgotten outbursts. What defies explanation is their stability. Without matter to anchor them, these fields should weaken and tangle over time, yet they remain organized as if guided by some unseen hand. Dark matter might play a role. Its gravitational influence could subtly sculpt the fields, or even interact with them in ways we don't yet understand. Alternatively, the fields might be constantly regenerated by cosmic rays zipping through the void, their high-energy particles injecting fresh currents into the abyss. This magnetized void challenges our assumptions about how energy persists in the universe. It's a place where the rules seem to bend, where emptiness holds more secrets than the stars. And somewhere in those invisible lines of force, there might be clues to one of physics' deepest mysteries, how the universe weaves order from chaos even in its loneliest corners. One of the strangest disappearances in modern astronomy unfolded near NGC 4889, where a small companion galaxy, documented in multiple surveys, vanished without a trace. Catalogued as a typical dwarf spheroidal galaxy, this faint collection of stars appeared stable for years, its position and structure carefully mapped. Then, over the span of just a few observations, it faded from view entirely, leaving behind empty sky where telescopes once recorded thousands of stars. The event sparked immediate debate. Was this a cosmic magic trick, or had we misunderstood something fundamental about how galaxies behave? The first assumption was technical failure. Astronomers scrambled to check instrument calibrations, archival images, even the alignment of telescopes, but the data held up. The dwarf galaxy had been real, and now it was gone. Unlike a supernova, which might outshine its host galaxy before dimming, this disappearance involved no flashy finale. The stars didn't explode, they simply vanished. One theory suggested rapid tidal disruption, where NGC 4889's gravity shredded the dwarf so thoroughly that its stars scattered into invisibility. Yet simulations showed this process should take millions of years, not months. A more unsettling possibility emerged: dark matter collapse. If the dwarf's structure depended on an invisible dark matter halo, and that halo somehow destabilized, the stars could lose their gravitational scaffolding, drifting apart like a sandcastle hit by a wave. Some models even propose exotic dark matter particles that might interact in ways we've never observed, triggering sudden implosions. Yet no known physics explains how this could happen so quickly. Then came the wildcard theories. Could the dwarf have been a temporary illusion, a chance alignment of background objects mimicking a galaxy? Or more radically, was it never a galaxy at all, but something else entirely? A cluster of primordial black holes, a defect in spacetime itself. Every explanation felt like grasping at cosmic straws. The truth remains hidden, but the implications are profound. If galaxies can vanish this abruptly, our maps of the universe might be far less stable than we thought. And somewhere in the darkness around NGC 4889, other dwarfs could be teetering on the edge of existence, here one moment, gone the next, leaving only questions in their wake. Millions of years ago, long before humans walked the Earth, a doomed star ventured too close to the sleeping giant at NGC 4889's heart and paid the ultimate price. While the violent feast is over, its echoes linger in the surrounding void, telling a story written in the language of light and motion. When the black hole's tidal forces first gripped the star, they stretched it like cosmic taffy, pulling it apart in an event astronomers call a tidal disruption flare. The outer layers were shredded into a swirling stream of superheated plasma, while the core, now a dense, misshapen knot, was flung outward at a fraction of light speed. For weeks, the flare would have outshone the entire galaxy in X-rays, a brilliant beacon signaling the star's death throes. Today, though the flare has faded, subtle clues remain. By analyzing the glow of ionized gas near the black hole, researchers have reconstructed the event like forensic astronomers. Certain elements, helium, nitrogen, and a surprising amount of lithium, are overabundant in the surrounding region, matching the chemical fingerprint of a medium-sized star torn apart mid-life. Even more telling are the velocities of nearby gas clouds. Some are racing away at over 2 million miles per hour, their motion aligned in a conical pattern that traces the path of the original explosion's shockwave. It's as if the ghost of the star's final scream is still pushing material outward, but the most haunting evidence comes from an unexpected source: reflected light. Just as sound bounces off canyon walls to create echoes, the tidal flare's initial burst illuminated nearby dust clouds, which are now re-emitting that energy as delayed infrared glows. By measuring the time lags and positions of these light echoes, astronomers have triangulated the original flare's position to within a few light days of the black hole, pinpointing where the star met its end with unsettling precision. The aftermath holds surprises too. Debris from the shredded star hasn't all fallen into oblivion. A significant fraction was flung clear, forming a tenuous nebula of stellar guts that now orbits at a safe distance. This nebula is peculiarly rich in molecules like carbon monoxide and water vapor, materials normally destroyed near black holes. Their survival hints that chunks of the star were ejected so violently they escaped the black hole's influence entirely, carrying pieces of a dead sun into intergalactic space. What was once a star is now a cosmic message in a bottle, floating through the void with its story etched in chemistry and motion. Perhaps the most profound lesson lies in the timing. Based on the debris cloud's expansion rate, this event occurred roughly 65 million years ago, around the same time an asteroid wiped out Earth's dinosaurs. While one world faced extinction, another met its end in the depths of NGC 4889, reminding us that the universe writes tragedies on all scales. Yet even in destruction, there's creation. The heavy elements forged in the star's death throes now seed new generations of stars and planets. Its final act wasn't an ending, but a transformation, one we're only now learning to read in the faint whispers of light and gas. Among the countless spectra captured from NGC 4889, one particular emission line stands out like a wrong note in a symphony, a spike of light at a wavelength that doesn't correspond to any known atomic transition in the universe. This spectral anomaly, a stubborn blip in the data, has astronomers torn between two possibilities. They've either stumbled upon evidence of physics beyond the standard model, or they're staring at the most frustrating instrumental glitch in modern astrophysics. The line appears consistently across multiple observations, always at the same precise wavelength, 872.4 nanometers, just beyond the red end of the visible spectrum. It's too sharp to be noise, too bright to ignore, yet it resists every attempt at identification. Teams have combed through databases of atomic and molecular transitions, searching for anything: exotic ions, rare chemical compounds, even hypothetical dark matter interactions that could produce such a signature. Nothing fits. The closest match comes from doubly ionized neon, but the energy required would demand temperatures far higher than anything detected in the region. One radical theory suggests this could be our first glimpse of actions hypothetical particles proposed to solve mysteries in quantum physics. Under certain conditions, actions might decay into photons with very specific energies, potentially creating emission lines exactly where this anomaly appears. Another camp argues for an undiscovered state of hydrogen, one where its electron orbits in a previously unimaginable configuration, releasing light at this peculiar wavelength. Both ideas would rewrite textbooks if proven true, but skepticism runs deep. Critics point to the possibility of overlapping lines from more mundane sources, like an unusual combination of carbon monoxide and water vapor in an extreme magnetic field. Others blame scattered light within telescopes themselves, where internal reflections could artificially shift familiar lines into unfamiliar positions. The most frustrating explanation: a software bug in one widely used spectral analysis tool, subtly distorting data in a way that creates this phantom line across multiple instruments. The debate hinges on a paradox. If the line is real, its implications are revolutionary, a crack in our understanding of matter itself. If it's an artifact, its persistence across observatories makes it the most convincing illusion in astronomy. For now, NGC 4889 keeps this secret close, its anomalous light a riddle wrapped in starlight, one that might take breakthroughs in both technology and theory to unravel. Like a cosmic rebel, a massive gas cloud whirls defiantly against NGC 4889's rotation, spinning backward as if the galaxy's rules don't apply. This counter-rotating maverick, spanning hundreds of light years, moves with such pronounced opposition that astronomers initially doubted their instruments. How does something so large move so stubbornly against the galactic current? The answer lies not in the galaxy itself, but in a violent encounter from billions of years ago. This isn't native gas, it's an interstellar interloper likely torn from a smaller galaxy that crashed into NGC 4889 at a steep angle. When galaxies collide, their gas doesn't immediately mix. It retains its original motion like cream swirling in coffee. the doomed galaxy's angular momentum, oriented almost opposite to NGC 4889's spin, imprinted onto this cloud, creating a celestial eddy that persists long after its parent galaxy was shredded. Spectroscopy reveals its alien composition, richer in heavy elements like oxygen and neon than the surrounding galactic medium, with distinct isotopic ratios that betray its external origin. The cloud's days are numbered, though. Every rotation brings it into contact with co-moving gas, creating turbulent shock fronts where the opposing flows collide. These regions glow fiercely in ultraviolet, marking where the rebel cloud is being gradually eroded, its outer layers stripped away and assimilated into the galactic mainstream. Yet at its heart, the gas remains stubbornly intact, protected by its own density. Some pockets are even collapsing under their own gravity, forming new stars that inherit their parent cloud's backward motion. These stellar oddballs will forever orbit against the grain, cosmic souvenirs of the cloud's defiant past. Watching this slow-motion demolition offers crucial insights. The cloud's gradual destruction maps the otherwise invisible forces shaping the galaxy's gas dynamics. Its persistence suggests NGC 4889's halo may be less turbulent than models predicted, allowing such anomalies to survive for billions of years. And its eventual fate, complete dissolution, will subtly alter the galaxy's chemical makeup, proving that even in death, cosmic rebels leave their mark. Buried within the depths of NGC 4889's core, something stirs. An unpredictable flickering in the darkness, like a distant lighthouse switching on and off at random. These sporadic flares, caught by X-ray and radio telescopes, pulse with energies that dwarf entire star clusters, yet vanish as quickly as they appear. They're the galaxy's cryptic heartbeat, raising a tantalizing question. Is the sleeping giant at its center merely rolling over in its slumber, or is it on the verge of awakening? The flares follow no discernible pattern. Some last mere hours, others flicker for days, their brightness swinging wildly by factors of hundreds. At their peak, they outshine the quiet glow of the surrounding accretion disk, hinting at violent but localized upheavals near the event horizon. One leading explanation points to instabilities in the black hole's feeding process. Like a starved fire suddenly gorging on oxygen, stray clumps of gas, perhaps the remnants of a shredded star or a destabilized gas cloud, might sporadically plunge inward, superheating as they spiral toward oblivion and igniting transient bursts of radiation. But there's a competing, more unsettling theory: magnetic reconnection. The black hole's monstrous magnetic field, twisted into knots by the chaotic motions of orbiting matter, could periodically snap and realign, unleashing pent-up energy in colossal flares. This phenomenon, familiar from our own sun's solar storms but scaled up to galactic proportions, would explain the flare's rapid rise and fall. Supporting this, certain flares exhibit polarized light, a telltale signature of magnetic activity, while others match simulations of magnetic loops collapsing near the event horizon. The real mystery lies in what these flickers imply about the black hole's future. Active galactic nuclei typically transition between states over millennia, not months. Yet here, the flickering suggests a system teetering on the edge of stability, where minor perturbations could tip it into full-blown activity. Imagine a dormant volcano venting sporadic plumes of smoke, not quite erupting but far from peaceful. If the flares grow more frequent or intense, they might signal the rebirth of a quasar, flooding the galaxy with radiation powerful enough to sterilize entire star systems. Oddly, not all flares originate from the same spot. High-resolution imaging reveals that some emerge slightly offset from the black hole's precise location, as if ejected from hotspots in the surrounding disk. These outliers could be evidence of mini-jets, short-lived plasma ejections that fizzle out before reaching intergalactic space. Alternatively, they might represent the death throes of asteroids or comets spiraling into the abyss, their final moments converted into brief, intense flashes. What makes these flares invaluable is their diagnostic power. Each one carries encoded information about the black hole's immediate environment, its magnetic field strength, the density of nearby matter, even the space-time curvature closest to the event horizon. By decoding their light, astronomers are piecing together a dynamic map of the monster's lair, revealing where turbulence reigns and where eerie calm persists. Yet the flares also serve as a humbling reminder. Even the mightiest forces in the universe are subject to fits and starts. NGC 4889's black hole isn't a steady machine but a capricious beast, its hunger and fury flickering unpredictably against the dark. And with every unexplained surge of light, it challenges us to reconsider what we thought we knew about how galaxies live, breathe, and sometimes shudder awake. Hidden among the glittering star clusters of NGC 4889 lies an anomaly that defies the eye, a globular cluster so dark it barely whispers its presence against the cosmic backdrop. This shadowy congregation, catalogued as VD309, weighs as much as a small galaxy yet emits less light than a single massive star. Its gravitational pull tugs mercilessly at nearby objects, betraying its unseen mass, but peer into its heart with even the most powerful telescopes, and you'll find only a sparse scattering of ancient stars suspended in what appears to be empty space. The disparity is staggering. Calculations suggest this cluster should contain hundreds of thousands of stars, yet fewer than 100 are visible. So where is the rest of its mass hiding? The most plausible explanation points to dark matter, the invisible scaffolding of the universe filling this cluster in amounts never before seen in such structures. Typical globular clusters are nearly devoid of dark matter, their gravity accounted for by visible stars alone. But here, something invisible dominates, outweighing the luminous matter by at least 1,000 to 1. If confirmed, this would shatter assumptions about how globular clusters form. Perhaps VD309 isn't a true cluster at all, but the stripped core of a dwarf galaxy, its outer stars torn away long ago by tidal forces, leaving behind a dense kernel of dark matter and a handful of surviving stars. Supporting this, the cluster's few visible stars are peculiarly metal-poor, matching the chemistry of ancient galactic building blocks rather than the more enriched populations found in most globulars. Yet alternative theories abound. Some astronomers propose the missing mass could be made up of failed stars, brown dwarfs too faint to detect, or black holes left behind by generations of supernova. Others suggest a swarm of rogue planets ejected from their systems and now drifting unseen between the stars. The wildest hypothesis involves primordial black holes, theoretical remnants from the Big Bang that might lurk in such clusters like invisible anchors. Each idea carries its own implications. A dark matter-dominated cluster would challenge models of galaxy assembly, while a population of hidden compact objects could rewrite our understanding of stellar evolution in dense environments. The cluster's very existence raises deeper questions. How did it form in isolation, avoiding disruption for billions of years? Why does its dark matter, if present, behave differently from the halos surrounding galaxies? Observations reveal another oddity. Its visible stars orbit erratically, some moving at right angles to the cluster's rotation, as if pushed by unseen hands. This kinematic chaos suggests the dark component isn't smoothly distributed but clumped in ways that scramble stellar paths unpredictably. What makes VD309 invaluable is its rarity. Of the thousands of globular clusters known, only a handful exhibit this extreme mismatch between mass and light. Studying it could reveal whether dark matter can clump on such small scales, a critical test for cosmological theories. Or it might expose hidden chapters in the life cycles of stars, showing how environments like this can produce legions of dark, dying suns. Every flicker of starlight from this shadowy gathering carries clues, and somewhere in its enigmatic heart, the universe has tucked away answers to questions we're only beginning to ask. Streaking across the outskirts of NGC 4889 like a comet without a tail, a vast cloud of hydrogen gas races through space at nearly 700,000 miles per hour, fast enough to cross our solar system in under a week. This high-velocity cloud, a nomad of the intergalactic wilderness, presents astronomers with a cosmic riddle. Is it plummeting toward the galaxy in a death spiral, being violently ejected, or simply drifting past as a temporary visitor? Each scenario paints a dramatically different portrait of the galaxy's influence and history. The cloud's trajectory offers the first clues. Its path traces a shallow arc across the sky, slightly curved as if responding to NGC 4889's gravitational pull. Spectroscopy reveals the gas is predominantly neutral hydrogen, cold and primordial, a stark contrast to the galaxy's own hot, metal-rich interstellar medium. This chemical purity suggests the cloud might be an ancient relic, a leftover fragment from the early universe that's only now encountering the galaxy's outer halo. Yet its speed complicates the story. If it were falling in naturally, gravity alone wouldn't account for such extreme velocity without additional acceleration. Some hidden force, perhaps a past interaction with another massive object, must have given it this extraordinary kick. One compelling theory casts the cloud as a fugitive, violently expelled from the galaxy's core during an ancient outburst. Active galactic nuclei, like the one that once powered NGC 4889's central black hole, can launch jets of material at relativistic speeds. Over millions of years, such ejecta could cool and fragment into structures like this cloud. Supporting this idea, faint X-ray emissions along the cloud's leading edge hint at shock, heating the telltale sign of gas plowing through the galactic halo at breakneck speed. If confirmed, this would make the cloud a fossil of the black hole's past fury, a cosmic cannonball still carrying momentum from its explosive birth. Yet another faction argues the cloud might be entirely unrelated, a passerby caught in the act of zooming past NGC 4889. Our own Milky Way has similar high-velocity clouds, some of which are thought to originate from the Magellanic Stream or other satellite galaxies. If this cloud belongs to an unseen filament of the cosmic web, its encounter with the galaxy could be fleeting, a momentary alignment that will leave both unchanged. The absence of heavy elements in the gas supports this interpretation. Pristine material like this often exists in the voids between galaxies, untouched by stellar furnaces. The most tantalizing evidence comes from the cloud's distorted shape. Its leading edge is compressed, as if plowing into an invisible barrier, while its tail stretches outward in wispy tendrils, likely debris stripped away by interactions with the galaxy's extended dark matter halo. Radio telescopes have even detected faint whispers of molecular hydrogen in these trailing filaments, suggesting parts of the cloud are dense enough to shield molecules from destructive ultraviolet radiation. These sheltered pockets could one day collapse to form stars, embedding foreign chemistry into the galaxy's outskirts. For now, the cloud's fate hangs in the balance. If it's falling in, simulations suggest it will take tens of millions of years to fully merge, its gas gradually mixing with the galactic reservoir to fuel future star formation. If it's being expelled, it may eventually escape into intergalactic space, carrying traces of NGC 4889's history into the void. And if it's just passing through, it will become a footnote in the galaxy's long history, a stranger that briefly shadowed its domain before vanishing into the dark. What makes this cloud extraordinary isn't just its speed, but what it reveals about the dynamic interplay between galaxies and their environments. Like a leaf caught in a whirlpool, its path encodes hidden forces, the tug of dark matter, the echoes of ancient cataclysms, even the tenuous currents of the cosmic web. And as we watch its journey unfold, we're reminded that even the emptiest corners of space are alive with motion, connection, and the slow dance of matter across time. Glowing eerily against the blackness of space like a cosmic fingerprint, NGC 4889's most peculiar planetary nebula holds a chemical secret. Planetary nebulae, the glowing shells of gas expelled by dying stars, typically follow predictable patterns, their compositions reflecting the nuclear fusion processes of their progenitors. But this one, catalogued as PNK 72, defies all expectations. Its spectrum blazes with bizarre overabundances of zirconium, yttrium, and even rare Earth elements like praseodymium. Metals so unexpected in such an object that astronomers initially suspected instrument error. The presence of these exotic materials points to a stellar death unlike any textbook model predicts, a demise so peculiar it might rewrite our understanding of how certain stars expire. The key to unraveling this anomaly lies in the nebula's central star, a faint white dwarf pulsing with unnatural rhythm. Most planetary nebula central stars cool steadily as they fade into oblivion, but this one flickers erratically, its brightness changing by up to 15% in mere hours, behavior typically seen in much younger, more massive stars. Spectral analysis reveals why. The star's surface is littered with freshly synthesized heavy elements dredged up from its interior, a toxic soup of metals that shouldn't exist in such concentrations. These elements act like chemical dyes, absorbing specific wavelengths of light and altering the star's apparent brightness as they circulate through its atmosphere. How did such exotic chemistry arise? One radical theory suggests the progenitor star was part of an ultra-rare class called born-again stars. Normally, when a sun-like star exhausts its nuclear fuel, it sheds its outer layers to form a planetary nebula before collapsing into a white dwarf. But in exceptional cases, a final helium shell flash, a last gasp of fusion, can reignite the dying star, causing it to balloon back to red giant proportions and begin burning elements like carbon and oxygen in bizarre secondary reactions. During this phoenix-like resurrection, conditions inside the star become perfect for the slow neutron capture process, or S process, which builds heavy elements atom by atom over centuries. When the star finally sheds these enriched layers, the result is a nebula like PNK 72, a celestial reliquary packed with forged metals normally found only in the debris of supernova. Another possibility involves stellar cannibalism. If the central star once had a close binary companion rich in these heavy elements, it might have consumed pieces of that neighbor during its death throes, incorporating foreign chemistry into its own ejecta. Supporting this, the nebula exhibits faint, asymmetrical jets, often a hallmark of binary interactions, and its expansion pattern suggests multiple ejection episodes separated by thousands of years. What makes PNK 72 invaluable is its role as a cosmic alchemist. The rare elements peppering its clouds are precisely those needed to form terrestrial planets like Earth. By studying how these metals were created and scattered, astronomers can trace the galactic supply chain that eventually delivered the building blocks of rocky worlds. Every anomalous line in its spectrum whispers a clue about how the universe transforms simple hydrogen into the ingredients for complex life, one peculiar stellar death at a time. Deep in the chaotic heart of NGC 4889, where stars whip around the supermassive black hole like moths circling a flame, astronomers have detected a gravitational anomaly, an unseen something tugging at the system with unmistakable force. The motions of nearby stars don't just trace the primary black hole's pull. They wobble, they stutter, as if compelled by a second invisible dance partner. The math is clear. Something massive, compact, and utterly dark shares this space, and the leading candidate, a binary black hole system, where two cosmic titans orbit one another in a slow, gravitational waltz that could rewrite our understanding of galactic cores. The evidence comes in subtle twists and turns. Precise measurements of stellar velocities reveal periodic deviations, stars speeding up unexpectedly before slowing down again, their paths bent by an unseen mass about 100,000 times that of our Sun. These perturbations repeat on a rough cycle, suggesting an orbital period measured in years rather than centuries. If this companion is indeed a black hole, it would be a rare intermediate mass specimen, bridging the gap between stellar mass black holes and the supermassive giants that dominate galactic centers. Gravitational waves add another layer of intrigue. While no direct detections have been made from this system, models show the hypothetical pair should emit faint ripples in spacetime, especially if their orbits are eccentric or inclined. Some researchers argue that unexplained noise in recent gravitational wave data could be the echo of their slow in-spiral, a whisper buried under louder mergers from across the universe. The timing is critical. If the two black holes are closer than projected, their gravitational wave signature might soon be detectable by next-generation observatories, offering the first concrete proof of their existence. But not all clues point neatly to a second black hole. An alternative explanation suggests these stellar motions could stem from a dense cluster of stellar remnants, neutron stars, and smaller black holes, packed so tightly near the core that their collective gravity mimics a single massive object. The problem: such a cluster would be dynamically unstable over cosmic timescales, prone to either collapsing inward or scattering apart. Only a true black hole binary could persist for the millions of years required to shape the orbits we observe today. The implications of a confirmed binary would be profound. Most galaxies are thought to harbor single supermassive black holes, but pairing two in one core suggests a violent merger history. Perhaps NGC 4889 cannibalized a smaller galaxy, capturing its central black hole in the process. Their eventual collision, billions of years from now, would unleash energy equivalent to 100 million supernova, briefly outshining every star in the galaxy combined. Until then, their gravitational interplay sculpts the surrounding stellar population, flinging stars into chaotic orbits or ejecting them entirely as hypervelocity runaways. What makes this candidate so compelling is its potential to test fundamental physics. A binary system would allow astronomers to study how black holes interact over long timescales, probing predictions of general relativity in extreme regimes. Do their event horizons distort as they orbit? Does frame dragging alter nearby starlight in detectable ways? Even negative results would sharpen our models, forcing theorists to reconsider how black holes pair up and evolve in crowded galactic cores. For now, the question remains open. A tantalizing maybe written in the motions of stars and the whispers of spacetime. Every new observation brings us closer to answering whether NGC 4889's heart beats with one monster or two, and what that might mean for the life cycles of galaxies across the cosmos. Tucked away in one of NGC 4889's spiral arms, a dense knot of stars glows with the faded brilliance of a bygone era, a celestial fossil frozen in time. This ancient starburst region, catalogued as SF-28, once blazed with the furious light of countless newborn stars, their collective energy rivaling quasars. Today, it stands eerily quiet, its stellar nurseries gone cold, leaving behind only the aging survivors of that frenzied epoch. What caused such explosive activity to abruptly cease, and why does this relic remain so strikingly intact? The evidence lies in the stars themselves. Spectroscopy reveals a population overwhelmingly dominated by red giants and supergiants, massive stars in their final evolutionary stages, their outer layers puffed up as they burn through the last reserves of hydrogen and helium. Their sheer concentration suggests this region once formed stars at rates hundreds of times higher than the Milky Way does today. Yet curiously, there are almost no young, blue stars to be found, and the surrounding gas, normally the raw material for new stellar generations, appears conspicuously thin. This paints a clear picture. Something drained the region's fuel reserves with brutal efficiency, starving future star formation before it could begin. One compelling theory points to galactic winds. During its peak, the starburst's countless supernova and stellar winds may have generated such powerful outflows that they expelled the remaining gas entirely, like a hurricane clearing dust from a field. Radio observations reveal faint traces of shock-heated gas stretching far beyond the region, fossilized bubbles marking where these violent winds punched through the interstellar medium. Without gas to collapse into new stars, the starburst simply ran out of fuel, but another possibility is more sinister. NGC 4889's central black hole during its active phase might have unleashed jets that precisely targeted this region. As the jets plowed through the galaxy, they could have superheated the starburst's gas, preventing it from cooling and collapsing into new stars. The timing fits. The starburst's estimated shutdown coincides with the peak activity period of the radio lobes seen earlier in our journey. It's a cosmic case of a monster quenching its own galaxy's fire. The most tantalizing clue comes from an unexpected source, the region's globular clusters. While most globulars in NGC 4889 are ancient, SF-28 hosts several unusually young ones, their stars chemically enriched by the starburst's rapid fusion. These clusters now orbit like celestial tombstones, their tightly packed stars preserving the conditions of that frantic era. Some even contain intermediate mass black holes, possibly the merged remnants of many massive stars that once dominated the region. What makes this fossil so valuable is its preservation. Unlike younger starbursts still shrouded in dust, SF-28 age allows us to study it clearly, like an archaeological site weathered by time. Its star's precise motions trace the gravitational scars of past interactions, while their chemical makeup reveals how efficiently galaxies can recycle material on grand scales. And perhaps most importantly, it serves as a warning, a preview of what could happen to star-forming regions across the universe as galaxies evolve and their gas supplies dwindle. Yet mysteries linger. Why did this particular region ignite so fiercely in the first place? Was it triggered by a galactic collision, a dense molecular cloud collapse, or some unseen dark matter disturbance? The answers might lie in its odd shape, slightly elongated, as if stretched by tidal forces long ago. And deep within its heart, a few massive stars still burn defiantly, their light a final echo of the firestorm that once was. They remind us that even in the quietest corners of the cosmos, the past is never truly gone, just waiting to be read in the light of surviving stars. Among the strangest whispers surrounding NGC 4889 is a claim that defies conventional physics, a rumored cosmic string lurking in its depths. These hypothetical space-time defects, thinner than an atom but stretching across light years, are predicted by string theory to carry unimaginable density, warping space around them like a crack in the fabric of reality. Some astronomers argue that peculiar gravitational lensing patterns near the galaxy's western fringe could hint at such an object, though the evidence treads a fine line between groundbreaking discovery and overeager interpretation. The anomaly in question involves a series of nearly identical galaxy pairs appearing in telescope images, duplicate images of the same background objects, aligned with geometric precision. Normally, gravitational lensing creates arcs or smeared shapes, but these duplicates are eerily symmetrical, as if space itself has been folded along a razor-straight line. Cosmic strings, if they exist, could produce exactly this effect. Their immense tension would slice through space-time, creating a gravity step where light bends sharply at the boundary, much like light refracting through the edge of a prism. The duplicates' near-perfect alignment and equal brightness differ from typical lensing artifacts, fueling speculation. Yet skepticism runs deep. Mainstream astrophysics offers alternative explanations, like an exceptionally narrow dark matter filament or an edge on dwarf galaxies so dense it mimics a string's lensing. Others blame overlapping instrumental glitches or the chance alignment of multiple lensing systems. The most damning counterargument: no accompanying time delays between the duplicates, which a true cosmic string should produce as light travels different paths around it. Without this key signature, the case remains circumstantial at best. What makes the debate valuable isn't just the remote chance of confirming a string, but what the search reveals about NGC 4889's hidden structure. The region's gravitational maps show unexpected linear features in the dark matter distribution, substructures that, while not proof of strings, suggest our models of galaxy formation might be missing a piece. Whether the culprit is exotic physics or mundane astrophysics, the anomalies push telescopic resolution to its limits, proving that even negative results can refine our understanding of the cosmos. Perhaps the most intriguing outcome is how the hypothesis has driven innovation. To test it, astronomers have repurposed optical interferometers and quantum-linked atomic clocks, seeking space-time distortions 1,000,000 times subtler than those detectable by gravitational wave observatories. These experiments haven't found a string yet, but they've sharpened our ability to measure space-time's fabric, turning a wild theory into a tool for discovery. In the end, NGC 4889's cosmic string may join the ranks of compelling mirages in astronomy like Martian canals or pulsar aliens that revealed more about our methods than the universe. But the search continues, because if even one such defect were real, it would rewrite the rules of cosmology, proving that the universe's deepest blueprints are woven with flaws we've only begun to trace. Tucked away in the outer halo of NGC 4889, something massive betrays its presence without a single photon of light, an unseen satellite detected solely by the way it yanks at the stars around it. This phantom object, known only through gravitational perturbations, refuses to show itself in any wavelength from radio to gamma rays, yet its influence is undeniable. Stars nearby accelerate inexplicably, their paths bending as if tugged by an invisible hand. The numbers tell a staggering story. Whatever lurks here has a mass comparable to a small galaxy, yet occupies a volume no larger than our solar system. The implications are as thrilling as they are unsettling. Dark matter is the prime suspect. Most galaxies are thought to be shrouded in vast halos of this mysterious substance, but typically it's spread diffusely. Here we might be seeing something far stranger, a dense, rogue clump of dark matter, somehow condensed into a tight knot that defies standard models. Simulations suggest such clumps could be remnants from the early universe, when quantum fluctuations created pockets of ultra-dense dark matter that survived cosmic expansion. If true, this object would be a Rosetta Stone for decoding dark matter's nature, its gravity offering clues about how the invisible scaffolding of the cosmos behaves on small scales. But dark matter isn't the only possibility. An equally compelling case points to a cluster of primordial black holes, hypothetical relics from the Big Bang, each no larger than a mountain yet weighing as much as a star. Thousands of these microscopic monsters could orbit one another in a tight swarm, their collective gravity mimicking a single massive object. Unlike modern black holes formed from collapsing stars, primordial ones would carry information about the universe's birth, untouched by billions of years of cosmic evolution. Their detection would revolutionize our understanding of the early universe, potentially solving mysteries like the origins of supermassive black holes. Then there's the wildcard scenario, an intermediate mass black hole, too small to power a galactic core but too large to form from a single star's collapse. Such objects are notoriously elusive, lurking in the cosmic shadows. If one drifted into NGC 4889's halo, it could explain the gravitational anomalies while offering a missing link in black hole evolution. Its presence might hint at a violent past. Perhaps it's the stripped-down core of a devoured dwarf galaxy, or a wanderer ejected during some ancient galactic collision. The unseen satellite's true nature remains locked in its silence. Every observation deepens the mystery. Stars near it show subtle kinematic quirks, some accelerating erratically, others orbiting in skewed planes that suggest an asymmetric gravitational field. These nuances could mean the object isn't a single entity but a complex system, like a black hole binary or a dark matter substructure tangled with rogue planets. What makes this ghostly presence so mesmerizing is what it represents: the universe's habit of hiding its most profound secrets in plain sight. Here, in the darkness beyond NGC 4889's glow, we're reminded that gravity alone can rewrite the story of a galaxy, no light required. And until the day we catch its shadow or measure its whisper in gravitational waves, this unseen satellite will keep its secrets, challenging us to imagine what else might be lurking just beyond the edge of vision. From the silent behemoth of a dormant supermassive black hole to the ghostly whispers of magnetized voids, NGC 4889 has revealed itself as a cosmic hall of mirrors, every object a riddle wrapped in starlight. Those 30 strange phenomena aren't just curiosities, they're pieces of a puzzle so vast it reshapes how we see galaxies. Take the runaway star fleeing at millions of miles per hour, the polar ring defying galactic rotation, or the phantom satellite detected only by its gravitational fingerprint. Each one forces us to question what we thought we knew. Even the stillness of that central black hole speaks volumes, proving that monsters can sleep, but their legacy lingers in the stars they've hurled away and the streams of stolen galaxies they've left behind. What ties these oddities together isn't just their strangeness, but what they reveal about the invisible forces sculpting the universe. The dark star cluster with its missing light, the gas cloud spinning backward, the flickering X-ray source with no origin, they all point to the same truth: galaxies aren't static museums. They're battlegrounds where gravity, dark matter, and time itself collide in slow motion. NGC 4889's quirks show us how mergers rewrite galactic histories, how black holes shape their surroundings long after going quiet, and how even the emptiest corners of space crackle with magnetic whispers from ancient cataclysms. But the real lesson here isn't just about one galaxy. It's about how much we've yet to learn. Every anomaly in NGC 4889, from the chemical chaos of that metal-rich nebula to the gravitational echoes of a possible cosmic string, is a doorway. Behind each one could lie new physics, new understandings of dark matter, or even new rules for how the universe stitches itself together. And that's the thrill of it. Galaxies like this aren't in points. They're invitations, so keep watching the skies, because somewhere out there, another NGC 4889 is waiting, another cosmic puzzle box, ready to spill its secrets when we ask the right questions. The universe doesn't just hide its wonders, it dares us to look closer, and as telescopes grow sharper and theories evolve, one thing's certain: the strangest discoveries are still ahead. After all, if a single galaxy can hold 30 mysteries, imagine what else is out there just beyond the edge of our understanding. The search isn't over. It's just beginning.